I'm Craig Keithley. I'm the Security and Cryptography Technology Manager. I have another role, which is also USB and FireWire Technology Manager. So if you've seen me in the USB and FireWire sessions, I do that too. And there's actually a little bit of an overlap. There's a number of security dongles that are USB based. So I take my skills from USB and I apply them to those as well. Today we're going to be talking about security in Mac OS X from a high-level kind of point of view. We'll be talking about the new features that have been added. One of the things I'm really pleased to be able to say is that starting with 10.0.3, we now have PCSC, or smart card support, built into the operating system. So without much further ado, I'll bring up John Hurley, who will give you the presentation on security overview. Thanks.
Okay, good morning, everyone. Good to have you all here. I'm going to try and give you an overview of the new security features that we put into OS X. We've been really excited to be able to work with 10. It's given us a lot of new possibilities. I mean, really the chance to actually start working towards a secure OS. So that's been great for us to work on. We have a lot of developer related features as well, so I'll try and indicate some of those, and we have sessions going on the rest of today as well with some of these things. I guess one of our biggest messages or design goals really is that we're trying to make the security in OS X configurable. So the default out-of-the-box thing that goes to the home user or whatever is going to have one configuration, and ideally they won't even really think for 2 seconds about security. It should just kind of be in the background. But we want to be able to enable all these other markets that really are interested in security, and see Mac OS X as a great platform to implement that on. Okay, so I'll talk about our architecture for data security, kind of how we see this all fitting into OS X, and I'm going to give you a pretty quick overview on the basis for the foundation for our security architecture, which is CDSA. As I'll explain in a later slide, it's Common Data Security Architecture. Give you a quick overview of the Keychain API. Ken McLeod is presenting a session later on today on that. And the Authorization API, give you a quick overview on that. And talk for just a very, very, very brief time about Core OS type security. Okay, so some of the opportunities that we've been able to really leverage on with OS X that we never had available to us before. Probably the biggest thing maybe is protected memory. We can have memory that's in a particular process, and unless you have root access, you can't actually see that memory. You can't really get to it. So we have, for example, we have a process called the security server, which contains the keys as they're used. Being able to leverage that is really great. It gives us a good chance to make things more secure. Being able to take advantage of the multitasking stuff means we can do things, we don't have to worry about being preempted or worrying about other processes that need to run. One really big advantage is that we have this whole BSD infrastructure that we can build on. So, there's a lot of security work that's been done on standard, Unix level security, and wherever appropriate, we've taken advantage of that. maybe one of the biggest things is that we've been able to have a fresh start. Of course, Classic still supports the OS 9 environment, but being able to move to this completely different operating system meant that we could kind of shake things up a little bit, and some of the things that had kind of gelled over the years we were able to get in at the beginning and start really implementing security from the beginning. Okay, now the last bullet here is the announcement, and this is really, we've been wanting to do this for a really long time, and we finally pulled it all together. So the announcement is that we're making most of our data security components open source. So they will be available. Yeah, we're really happy about it because it just gives us so many advantages. One of the things with security is peer review. It's really, you can't do security through obscurity. You have to have people being able to look at the code and try and find holes. And so it's great that we're able to do this. We've open sourced pretty much everything that makes sense from a Darwin perspective. So the idea is that if you have your Darwin system, you can compile that. These are all the components that you could compile in and get working without, it doesn't have, say, the high-level UI components, but all the low-level stuff, all the cryptography, the CDSA plugin modules. Actually, the next slide sort of talks about that. Makes it a little bit easier for us to do export compliance. And the last point is really important. We really value your contributions. I mean, the open source community has been great in looking over things and providing suggestions and code and whatever. So we're really looking forward to getting that input from all of you out there. So in more detail, the things that we're making open source, the security.framework, all the sub-projects of that, so the authorization sub-framework, secure transport, which is our SSL implementation that ties into CDSA and all that, so that's in there. Keychain, not the highest level APIs because those are actually in Carbon, and so that's not open source, but you can do all the keychain functionality with these lower level APIs. And the code for security server. All of the plugin modules for CDSA, so the data library and cryptographic service provider. There's some ASN1 code. There's a lot of good utility code. There's a lot of really, really good stuff in there. So we're really excited to be able to make that available. I'll just have to mention what the web page is because this just went live last night. So of course it didn't make it on the slides, but if you go to www.opensource.apple.com, you can find the little blurb on security, and that tells you where you can get the source from and all that. Oops. There you go. Okay, so talking just briefly about the keychain. This is a feature that a lot of you will be familiar with from OS 9. A lot of the look and feel of it is very much the same as it was on 9. I think the biggest thing to realize is that on OS 10, every single user has a keychain. So you can pretty much count on that. I mean, even on 9, if they didn't have one and you used it, it would come up and give them the dialog to create one. But on 10, when they log in, they have a default keychain that's created with their login password. And all the system services use that to store their passwords. So, for example, mail or can't think of the other ones now, but anyway, with iTools and and whatever. So all those passwords are stored in the user's keychain. And we've actually done a really good job of kind of making that transparent. So you log in, by default it's unlocked throughout the whole time that you are logged in. But of course you can change that setting so that it automatically locks or whatever. The idea is to make it as simple as possible kind of for the average user, but if you're more security conscious, you can do things like make it lock more frequently. The biggest message that I have to say about that, and of course Ken will go into real detail about how to use it, the biggest message I have is if you need to save a password, use the keychain to do it. It's really, really easy. You only need like basically 2 calls. You find it to see if it's there, and if it's not there already, you can add it. That's it. And you know, it's very, very small amount of code. It will save you perhaps some embarrassment if you didn't quite implement it right. I mean, we've gone to a lot of trouble to make sure that the keychain file is protected, and applications that are not allowed to use a particular password or, you know, will either warn the user or prevent them from doing so. So we put in a lot of work. It's easy for you to use it, so that's my big message to you is just use it. If you have passwords, store them there. As I said, it's mostly transparent to the users. We've really changed a lot since OS 9. Probably a lot of you are familiar with the old rogue app alert that would pop up a lot, but we've managed to, because of the capabilities of OS 10, we've finally been able to do that kind of the right way, and so the rogue app alert just doesn't show up. It really only shows up when it's supposed to. And it's an API that's available through Carbon, or you can now also call these lower level APIs that are part of the open source. Okay, a completely new API that we've introduced on 10 is the authorization API. And I think right after this session, Michael Brower is doing a complete walkthrough of all the API calls and all that. But I did want to spend some time here just so that people at least understand why we did that, and why it might be worth your while to go to the next session to hear more about it. One thing we realized looking at, well, even on 9, but particularly on 10, there are a lot of places where the user needs to, say, enter their admin password to do something. So we've kind of locked it down a little bit so that you can't accidentally make a mistake or whatever. But initially, different groups at Apple were kind of doing it a different way, and they would check it here, and there was no real central way. So one thing we did was we kind of went around to all the groups and said, okay, let's funnel through this one bottleneck, and with the idea that for any given operation that you're doing, you can basically find out from the user or find out from some settings that maybe the administrator of the machine has configured. You can find out whether they are allowed to do that operation at that time. And bottlenecking it through one spot allows us to do a lot of great things, like being able to, say, cache the password for 5 minutes or something like that. That just kind of streamlines it a little bit for the user, so they're not typing this password in all the time. So from a really high level, the authorization API is basically, it's trying to answer a yes-no question. Given an operation, am I allowed to do it right now? And I guess the really interesting part comes through maybe the side effects, which is, okay, how do you figure out whether they are allowed to do that or not? And one of the basic side effects that can happen there is it may call off to these plug-in modules that we have to do different types of authentication. So let's take the really, really simple example of if you have the prefs panel, you have the little lock, you just want to know whether you are allowed to turn on your screensaver or something. So if you click on that lock, it might do a very simple authentication thing. It might say, oh, is this user the administrator of that machine, and does the password match? Okay, you're allowed to do it. But through this API, we've set it up so that you can plug in different modules, and those could get evaluated and return, ask for different types of authentication from the user. For example, as Craig mentioned, with the PCSC stuff, now we can do smart card stuff. So you could be getting information off a smart card, or voice print, or fingerprint, whatever. There are a lot of different things that you can do, and it's set up so that you can chain a whole bunch of these together and get answers from each one of them. I guess one other thing that I want to point out is that it does not give you the ability to do a particular operation. It's kind of assumed that it's being called from a trusted app that could do it anyway. So it's really, in a way, it's really a convenience or a service to the user, that you are asking the user whether or not you're allowed to do this operation. Because of course, if it wasn't a trusted process, they could just, well, not call the API and just bypass all that authentication stuff. So that's something to keep in mind, that it's not really providing the capability. And as Michael will say later on, you'll end up needing to have probably a SetUID root tool or something like that that can do, if that's what would be required for the operation. The authentication modules could do a couple different things. They might figure out who you are. So, for example, look you up in some directory services database or NetInfo or whatever. Or it could be looking at, say, a fingerprint reader. The three things I list there are kind of the security questions that you want to find out about authentication. Could be who you are. So that's actually something like a fingerprint. What you know would be like a password, and what you have might be something like a smart card. So if you have all three of those together, then you've really added some security to the system. One other thing with these authentication modules is that they may generate some sideband information that's needed either for the next module down the line or for the ultimate service that may need something. Like, for example, let's say you're logging in with Kerberos. You need to know not only username and password, but you also need to know the realm. So those would be things that would get passed along so that at the end of the operation you would know what you needed to know to move forward. And then the last point is, in a lot of cases, this operation might just succeed. Like the answer to the question, can I do this operation? The answer is always yes. It never does anything, never throws a dialogue, never asks the user at all. The point is that you can configure it for these different operations. So if you're in a more secure setup, you could lock that down more. So we're moving towards getting all that stuff working nicely. Okay, so just an example of probably maybe a typical operation you might think of for authorization. Let's say you're logging into the console. You could have several different steps that you might have to go through. So you might have to type in your username and password. The username, for example, can go look off in a directory somewhere and figure out where your home directory is and all that. The password, ideally you want to ask the user for that because then they can unlock the keychain. You might have to insert a smart card or fingerprint reader or voice recognition. Some of the operations that you might be able to do, I mean, logging in is an obvious one, but unlocking the screensaver, you know, it would be nice to be able to step up to your machine and as you walk back to your office say, hey, I'm back, and have the screensaver just unlock without having to type a password. Playing a CD is something that comes up a lot in K through 12 market. The teachers want to restrict what CDs the kids can play. So that's an operation that, you know, that we can, by calling the authorization API, you could set it up to configure it so it could go off and look up in a playlist whether or not it's actually allowed to play that CD. And format a disk, that's kind of a good one to, you know, to turn on for your kindergarten kids so that they don't format your stuff. Okay, so anyway, there's a more detailed session on that next after this. CDSA is the foundation for this security architecture that I've been talking about. The keychain is based on it. The secure transport stuff uses all that. All the cryptography stuff that we do goes through this. It stands for Common Data Security Architecture. Originally it came from Intel, but now it's an open group standard. And on OS 9 we implemented the 1.2 version of the standard, and we learned a lot from doing that and contributed a lot to the next version of the standard, which is 2.0. So that's what is in OS 10 is the 2.0 standard. I guess one of the biggest features that stands out about CDSA is that it uses plug-in modules to do a lot of the work. So, for example, the data library module or CSP, cryptographic service provider, you can plug in, you can write a module to do different types of crypto. Certificate library and trust policy module. Oops. There we go. Here's kind of a, I don't know, really rough block diagram of how these things are laid out. Kind of the pieces in purple at the bottom are the plugin modules, and the CSSM layer is the kind of guts of it that loads the different modules and helps them interact with each other. The layers in red are just some of the sort of middle layers that we've written on top of the CDSA APIs. CDSA is a pretty extensive standard. I mean, the manual is about that thick, you know, like 1,300 pages. So there's tons and tons of APIs. But we found that when we were using them, we kind of tended to group them together and, you know, maybe use them in a particular way. So a lot of the stuff that you would see in security core, for example, which you can see in the open source archive, those are collecting together these CDSA functions. Security HI is the user interface stuff that you might see, like the dialog that pops up to enter your password. Secure transport is our SSL implementation that uses our certificate libraries and things like that. And then you can write apps on top of that. I guess the biggest point is that if you're writing to the APIs on top, even if the plugin stuff changes below, your application isn't going to have to change. So you can really leverage, as people develop more stuff below, your app can just, you know, if there's suddenly a hardware crypto module, then you could take advantage of that. Data library modules are basically the storage information or storage module for CDSA, and it stores things that other modules might need. The keychain is basically the Apple file CSP DL, so it's a combination cryptographic service provider and data library module, and that way when we write the keys out to the file, we can do the encryption at the same time. We could have done it as maybe separate ones, but it just turned out to be convenient to put it in one module. Another example of a DL that we don't have now, but would be not too hard to write, it would be an LDAP DL. So you could store things, particularly say certificates or something like that. You could store them in a public LDAP directory. Certificate library modules, roughly it just knows how to parse a public key certificate. So the one that we ship by default, it does X509 version 3 certificates, and for a particular field in the certificate, the layers up above can ask, okay, what's the modification date on this, or who signed it, or whatever, and the certificate library knows where in the certificate to grab that value. It would be possible to write one that would know how to deal with a PGP certificate or attribute certificates, which contain, it's basically a way to take a bunch of attributes about something and then sign it so that it's a little bit more certified, maybe. Trust policy modules, this is an interesting one because I think this is one that a lot of corporations or universities might be interested in writing, because the standard one that we ship basically says, okay, given a chain of, or given a certificate, how do you know whether or not the user trusts that? And so the standard one that we ship for X509, we look, given a certificate, we see who signed it, and then we see who signed that, and finally we get down to a list of trusted root certificates. And if it matches one of those root certificates, then we say, okay, it's trusted. But it could be that you don't necessarily want to do it that way. One example there is you could do a web of trust. So you could say, okay, I'm only going to trust it if my pal trusted it. And so that would be a different way to implement a TP. Or you could go look it up in a corporate database. So there's a lot of different ways that you can change how certificates are trusted on the system by writing a trust policy module. Okay, as Craig mentioned before, we in software update 10.02, the binary for PCSC is available, so people can write drivers for smart cards. I think the SDK is posted on the security page, so for actually developing it, that's available there. We wanted to make sure that it was easy using this API to get to the CDSA APIs, and try and make it pretty easy. If you had an application that was already using PCSC on another platform, you'd at least be able to bring over that portion of the code pretty easily onto 10. We tried really, really hard to make it very easy to write a driver for the different readers, and there are several manufacturers that have already completed, they haven't shipped them yet, but they've completed drivers for different smart card readers. And for different types of smart cards, you can actually write a different CSP to use the cryptography that might be on the card. Here's kind of a, I don't know, complicated diagram with how this all fits together. You can see down at the bottom that the readers and the cards are down there. The idea is basically that you have the applications at the top, and if they're calling through these APIs, they don't really need to know any of the details. I mean, PCSC can deal with, it deals with all the resource management. So for example, if you have if you're in a situation where you have like 10 different readers plugged in and they all have different kinds of cards and whatever, this sorts it all out. It knows whether several applications can talk to a particular reader at once or whatever. So all those details are basically taken care of for you. Okay. So as I said, I just wanted to talk briefly about core level security. This is an area, of course, that a lot of you, if you're familiar with Unix, then you know a lot of these things that security features that you can use. Basically, OS X ships with most of the services turned off. So, FTP and Telnet, things like that. The average user, the average Macintosh customer, if they're not familiar with that, it's safer to just leave it off. And if they find out, or if they're interested, they can go and re-enable that. We turn off the root password by default, but that can be re-enabled. And I think that was one of the very common questions. People weren't complaining that we had turned off root. They just wanted to know how to turn it back on again. So there's a tech info library note on that. If you search the TIL database, you can find that. File permissions has been one of the areas that's been pretty tricky to figure out, and I think roughly the basic goal is we're trying to make sure that it works the right way with OS 9, and so a lot of those things are maybe not set the way that you're used to, say, from another Unix system, but they're set up to work. To interoperate with Classic and things like that. I guess the biggest thing is there are a lot of different books on Unix security, and most of those things apply on Mac OS X. So I would say, look to the resources that you know from that area. We try and keep things pretty much standard if we can at that level, and as we hook it more up into the upper levels, we try and keep the behavior pretty much the same as you're used to. Let's see. Not much else I have to say about that. I think they talked a little bit more about this in the BSD session, too. So here are some of the resources for these things that are available. The security webpage at developer.apple.com has some good links off to our software and to some other links that are interesting. Can find the specifications for CDSA at the Open Group. We also have a pointer there on the security webpage. And as I mentioned, the www.opensource.apple.com has our source. Sorry. Again, here's another thing that just came up, so it's not on the slides, but I'm glad I remembered to talk about it. We have posted a security web page. A lot of people had kind of been wondering, how we would deal with things like cert advisories and just security holes that might pop up in OS X. So sorry that this isn't on the slide, but again, this page went live yesterday. So If you go to www.apple.com /support/security, I think and then security.html, that has a whole page that it's designed for people that they think they've found a security problem with OS X, or they may need some security assistance, and that page contains the resources that kind of tell you how to deal with that incident. So it's a central point for kind of reporting problems. We have a team within Apple, so that stuff gets distributed really immediately, and it gets routed to a lot of different groups. Each group will kind of look at it and determine if it's something that is in their area of responsibility, and we'll try and fix it as quickly as possible. We of course have the software update mechanism, so we have been able to actually already release some fixes in each of the software updates that's gone out so far. I think we've pretty much shipped pretty much once per month since we released OS X. So we can deal with those pretty quickly. So that's a good resource to go to. Here are some of the related sessions that I mentioned. Right after this is the authorization API session. At 2 o'clock is the session on the keychain, learning how to use that. Tomorrow afternoon there's a session on Kerberos. Talk about what we're doing with Kerberos. And on Friday there's the feedback forum. So actually I can, here's person to contact, Craig Keithley, started out here. So that's his email. I think you can also find that on the web page. If you have any questions, particularly if you're interested in developing security-related products, he can find all the right resources for you.